what is a function? But before coming to the definition of a function, we'll consider example. And for this example, I've considered a very simple example: y is equal to 4x. And to go to the definition of a function, I'll make these kind of two shapes. We call it an arrow diagram. This first shape will represents the value of domain. Let's suppose we can take the different, we can take any number in domain. If I consider 1, a 0, or 2, and this portion of the arrow diagram give us the value of range. Function, this domain is also known as input value. Like if we consider x is equal to 0 and we substitute x is equal to 0 into y is equal to 4 of x, so we would see that there would be some process, and that process will give us output. That output is known as the value of range. So against value of x will get a value of y. Okay, this arrow explains that we get this value of y under this function, which is called y is equal, it is a function y is equal to 4 of x, and we call y is equal to f of x. So just to for our ease, we call it uh, under f is a function. Like if we take x is equal to 1, so what do we get? F of 1, so it is 4 times of 1, so we'll get 4.
Yes.
Okay, and this is under f. And for 2 we'll get 2, and likewise we can take any value of x, and for that value of x we'll get some value of y. Okay, so this is one example. Now if we move to another example, y is equal to f of x, and the function is y is equal to x square. We call it a function g of x. Okay, for domain, if we take value of x is equal to 0, and we get a range 0. If x is equal to 1, then range value is 1. When x is equal to minus 1, range value is 1. And for 2 and minus 2, okay, for 0 we have got one answer. For 1 under the function g we'll get 1, and for minus 1 we under the function g again we have got this, and for 2 under the function g, and for minus 2 under the function g.
Okay.
H of x is a function in which root of x. For 0 we'll get 0 under h, this is range. If we take 1, we'll see that we'll get
Minus
1
one.
and minus 1. And if we take 4, we can take value of 2 or 3, but due to this root we'll get decimal answer. So just to avoid that decimal option, I have considered 4, because if we take 4, we'll get one answer is plus 2 and other is minus 2. Now let's see what's happening in these three examples. For each value of x, we got one range value. This is what happening in example 1. Okay, for this,
This way for range.
in this we are not getting one for each value of x. We are we have two values of x and we are getting one answer of y. So if I use the term many to one, many to one mean we have more than one value of domain, more than one value of domain, there is one value of range. And here we have seen that for each domain there are more than one range values. Okay, when we get for each domain value and we have got one range value, we call it one to one. If we use the term, this term is one to one. Okay, this term is one to one. If we have more than one domain value, I mean more than one domain value, it means there are many values of domain, and for all those many values of domain we are moving to one range value. Okay, and if we use the term for example number 3 is one to many,
One to many. Okay.
we'll say that whenever you have a situation one to one, so you would call that it is a function. Whenever you have a situation many to one, again this situation will fall into the function, but one to many is not a function. Okay, is it clear? So 1 to 1 is a function, many to 1 is function, one to many is not a function.
If it's
There's
not a function, then
hmm,
what would we call it?
we call it in mathematics, we call it a relation. Okay, we call it a relation. All right, one to one is a function. We are again coming back to example number 1, and if I write this x and y as a point, as we have discussed that value of x is called domain and value of y is called a range value. So from example number 1 we can write the domain and range into a point form. So for point 1 range value is 4, for point 2 range value is 8, right? Is it clear? Can we write it? Okay, 1 to 1 is a function. So in example number 2 it is 0 and 0, and then 1 and 1, then minus 1 and 1 for 2 and 4, and it is minus 2 and 4. So similarly in example number 3 we write it 0 and 0, we write it 1 and 1, we write it 1 minus 1, we write it 4 and 2, and we write it 4 and minus 2. This is minus 2. Okay, there is another type of definition for the function. If we write that definition, if domain elements are not repeating, then f is called a function. Okay, so you can see in this example, I mean in this point this is 0, in this point this is 1, and in this point this is 2. So all domain elements are different, so domain elements are not repeating. I think it's better if I move to example number 3. So in example number 3 you can see that domain elements are repeating, as domain elements are repeating, so h is not a function. So whenever you find even in 2 points domain elements are repeating, so you would call that relation is not a function. You can see that 1 is repeating, you can see that 4 is repeating, I mean
Yes.
domain element is repeating. So whenever domain elements are repeating, so that relation will not be a function. If domain elements are not repeating, see this, in this example domain element is 1, in another point domain element is minus 1, and then 2, and then minus 2. So domain elements are not repeating, as domain elements or not repeating. So g of
Okay.
x is called a function,
Okay.
right?
Yeah.
Okay, there is another explanation to check about a relation whether it is a function or not. You can plot the graph.
Okay.
So if we plot this graph in which x is equal to 0, if this is y is equal to 1, x is equal to 4, this is the point. When it is 2, this is 8. So from here we can plot a line which will pass through the point. So we can draw the graph on both sides because domain value can be positive or negative. So this is a line. So we use a test which is called vertical line test. Okay, vertical line test. So in vertical line test, if line intersect the graph at one point, okay, if intersect vertical line intersect the graph at one point, then a relation will form a function.
Oh, okay.
Okay, this example, I mean this vertical line test is another way of judging about a relation whether it is a function or not. So the best way is you plot a graph and then draw different vertical lines at different positions just to check that in every position your graph will intersect, your vertical line intersect the graph at one point. Likewise, if we move to next example, and in this next example, if we plot for x is equal to 0 and if x is equal to 1 and then x is equal to 2, so x is equal to 0 and I'll get this kind of graph. This is y is equal to x square graph, and if I plot this vertical line, so I would observe that my line will intersect the graph at one point, so we can conclude that g of x is a function. Okay, so
Yes.
for example number 3, for example number 3, the function was h of x, which is equal to plus minus root of x. And if I plot a graph for this, just for your convenience, you know that this is for domain value and this is for range value. If we take x is equal to 0, then range value is 0. If x is equal to 1, due to plus and minus sign we got two answers, and for 4 and we'll get two answers. Okay, let us plot these values. For x is equal to 0 it is 0, for x is equal to 1 it is 1, then 2, then 3 and then 4. X is equal to 1 and minus 1. When x is equal to 4 it is 2 and it is minus 2. Likewise, if we extend the line and I consider 5, 6, 7, 8 and 9, and for 9 it would be plus 3 and it would be minus 3. So if I join all the points, I would see that this graph will move like this and the negative part of the graph will move like this. Okay, here when I draw the vertical line, so all the vertical lines you would see that all the vertical lines will intersect the graph at 2 points. If I plot vertical lines at different positions, so I would see that we have 2 point of intersection with this vertical line test. So with this test we'll be able to write that h of x is not a function.
Yes.
Okay, as vertical lines are intersecting,
At 2 points.
yes, the graph at 2 points. Got it? So from this whole thing, if we conclude how to check about a relation to be a function, we normally apply two methods. One is we'll check domain elements. If domain elements are repeating, if domain elements are repeating, or it would not repeating. If domain elements are repeating, we say that not a function.
Yes.
If not repeating, we say that a function. The relation will be a function. Okay. The other thing is vertical line test. So in vertical line test, intersect the graph at one point. Intersect the graph at 2 points. We call it intersect at one point, we call it a function. Intersect at 2 points, not a function. So we apply method number one or method number two. Okay, so whenever you have a graph or you plot a graph, maybe you'll be given a graph in the question, then directly apply vertical line test. And if your vertical line intersect at 2 points, so simply you'll write it is not a function. If it is I mean you have been given as a function, then you can plot the graph and then apply vertical line test. Otherwise, draw an arrow diagram, take some domain value and put and out of and against those domain values find the range values, and then make a comment by looking at a repeating domain number and not repeating domain number. So these would be, there would be two methods which will help to figure out about a relation to be a function.